Hello guys, welcome again to the Choya e-learning TV. Today I want us to tackle a question in differentiation, which is a topic in Form 4 under applications of differentiation. So we are presented with a question. A particle moves in a straight line such that after t seconds its displacement s meters from a fixed point is given by s is equal to 4t minus 2t squared minus 5t cubed. Find the velocity at t is equal to 3. So when given that question, and we are given the expression for distance, s represents distance, 4t minus 2t squared minus 5t cubed. For us to get the expression for velocity, we will differentiate the expression for distance. In other words, differentiate s with respect to t. So we'll come here and write the expression for distance as s is equal to 4t minus 2t squared and then minus 5t cubed. So differentiate s with respect to t. In other words, you say ds dt will be given by, so differentiating 4t, remember when we differentiate um, a t to the power of m, we take, assuming this is y is equal to this, in other words, we say dy dt is equal to, so we take a multiply m, then t raised to m minus 1. This is what we apply when we are doing differentiation. So we will come back to our question. Differentiating 4t, we will get, remember t is raised to the power of 1, so it will be 1 times 4. 1 times 4 will be 4. Then t, 1 minus 1 will be 0. So minus differentiating 2t squared, 2 times negative 2 will be negative 4t, 2 minus 1 will be 1, and then minus 3 times 5 will be 15t raised to the power of 3 minus 1 will be 2, meaning that our ds over dt is giving us a number raised to power 0 is 1, so it will be 4 times 1, which is 4, minus 40, then minus 15t squared. Now this is the expression for velocity. In other words, I can write it as v is equal to 4 minus 40, then minus 15t squared. So the question is, find the velocity at t is equal to 3. So if I equate t to 3, wherever there is t, I put 3. So I put 3 here, I also put 3 here. So velocity will therefore be 4 minus 4 into 3, then minus 15 into 3 squared. So this will be 4 minus 12 minus, this is 9, 15 times 9, 15 times 9 will have 15 multiply 9. We get 135 minus 130 and 35. So this will be 4 minus 12 minus 135, 4 minus 12 minus 135, you get negative 143. So this will now be minus 143 meters per second. That is the velocity when t is equal to 3. Part B of the question, We are told the time when velocity is 0. The time when velocity is 0. So what will be the time when velocity is 0? So we'll come and look at the expression for velocity, this one here, and equate it to 0. In other words, form a quadratic equation which we can be able to solve. So if I write this equation properly so that we start with t squared, we shall have negative 15 t squared minus 4t and then plus 4 is equal to 0. So to make it look better, you can decide to divide through by -1. This by -1, divide this by -1, divide this by -1, divide this one also by -1. So you'll get positive 15 t squared plus 40 minus 4 is equal to 0. When you divide a positive by a negative, you get a negative. A negative divided by a negative is a positive. Negative, negative, positive. So this is a quadratic equation. How do I solve it? I can pick two numbers whose product is 15 times -4, which is negative 60, and whose sum is positive 4. Two numbers whose product is -60 and whose sum is positive 4. So those numbers are supposed to be -6 and positive 10. We call them the roots. They are supposed to be positive 10 and a -6. So then you come and rewrite this equation. You rewrite now this equation as, so you will write the equation as, so the equation, if we rewrite it, becomes 15t squared. So it becomes 15t squared plus 4. Now we will need to expand 4t. We will expand 4t, the middle term. The middle term should be expanded using these two. So instead of writing 4t, you write 10t minus 6t. So you come here and write it as 15t squared plus 10t minus 60 minus 60, then lastly minus 4. Minus 4 is equal to 0. So that is 15t squared plus 10t minus 60 minus 4 is equal to 0. So that if you factorize now, you shall have 5t is common, open the bracket, you will have 3t plus 2, 3t plus 2, then minus 2 into 3t plus 2 is equal to 0. Like terms, now we take these two terms and group them together. So we shall have 5t minus 2. And since these two are similar, we pick one of them as 3t plus 2. Then we equate this to 0. So we can say either 5t minus 2 is equal to 0, meaning that t will be 2 over 5, or 3t plus 2 is equal to 0, meaning that t will be -2 over 3. But since time cannot be negative, since t cannot be equal to negative, we will therefore say that the correct value of t should be 2 over 5 seconds. 2 over 5 seconds. That is the end of part B. Then when we come to part C says calculate or find acceleration at t is equal to 2. Find acceleration at t is equal to t is equal to 2. So how do we find acceleration? So to find the expression for acceleration, we usually differentiate the expression for velocity. To find the expression for acceleration, we differentiate velocity with respect to t. In other words, the expression for velocity is this one here. This is the expression for velocity. V is equal to 4 minus 4t minus 15t squared. So let me write it here as V, so part C, V is equal to 4 minus 4t is 4 minus 4t minus 15t squared. So if you differentiate velocity with respect to time, in other words, dv over dt, this one will give you a 0. This one will give us, remember there is a 1 up here, so 1 times 4 will give us a 4 minus, and then 2 times 15 will be 30 t. 2 minus 1 will be 1. So we'll have this. This is the expression for acceleration. So acceleration is given as 4 minus 30 t. We need to find acceleration when t is equal to 2. So if we substitute where there is t, we put 2, acceleration will be given as 4 minus 30 multiply 2. So acceleration will be 4 minus 60, which of course will give us negative 56 meters per second squared. So that should be our acceleration. So then that sums up our problem. So we've fully solved our problem. And for more questions, kindly hit the subscription button, subscribe to the Chwea e-learning TV for more questions tomorrow. Thank you and have a nice time, and all the best to the candidate class.